Hello ladies and gentlemen, welcome to chapter 18, air pollution. 18.1, which is the nature of the atmosphere. I don't know what accent that was, I'm sorry about that. So what is the nature of the atmosphere? Let's go through the atmosphere. It's actually really freaking cool. Okay, so what is the nature of the atmosphere? Look at it in all its glory. We're looking here at a picture of predominantly clouds. Clouds is a bunch of what? Water vapor, good. All right, and these clouds would be in what layer of the atmosphere? We haven't even covered them yet, so this is just seeing your prior knowledge here. If you said troposphere, you are correct. Now the troposphere, true or false, is the layer of the atmosphere in which you live. That is true. You guys are so smart. I'm so proud of you. Okay, so the atmosphere. Gases that envelop the Earth and are held here by gravity and also regulate temperature. We're going to go through some of this temperature in a second. Yes, so the reason why we have gases that surround us is because of gravity. Without gravity, these gases that would be produced would escape out into space. Right? But gravity, like it does to everything else, holds it towards the surface. And we need them because without these gases, we wouldn't be here. And I'm not talking about just the greenhouse effect. I'm also talking about the ozone layer, right? All of those gases are held by gravity, and we need them all. So, major gases. These are the top ones that you guys are responsible for, and these are the ones that they have hit, and you know they always form random questions on the AP exam, knowing the basic ratio of gases in the atmosphere. So, 78.08 is the exact percentage of nitrogen. Remembering 78% would suffice. 20.95% oxygen. Remembering 21% oxygen would be good. 0.93, 0.9% argon, and then 0.03% carbon dioxide. Okay, so these are the four main gases. And you can see the percentage of carbon dioxide in the atmosphere is not that much. It's still one of the four main gases, and it's the gas that we're constantly talking about due to climate change, due to the burning and consumption of fossil fuels, etc., etc. So you can see that a small quantity of this gas can have a very large effect. Argon. You guys are probably like, what the heck is argon? We never even hear of it. It is an inert gas. And do you know what that means, to be an inert gas? That's right. It means it's non-reactive. Good. So we use this non-reactive gas in different functions. One of them is the windows that are in your house right now. If you go and look at them, your windows are most probably two-pane, meaning double-pane windows, right? There's a layer of glass, an air space in between, and then a second layer of gas. Now, what is in between them? It is not just air, because air, right, would have nitrogen, oxygen, some argon, some carbon dioxide, probably some hydrogen. You probably have some water vapor in there. And as the temperature throughout the course of the day changed, you'd get condensation in your window. It would be terrible. So what they do is they fill it full of argon, so that way you get nice clear visibility through your double pane insulating windows. Beautiful. You also have lots of trace amounts of other things. Water vapor, only 0.1% near the poles, but 4% near the equators, and lots of other things: hydrogen, neon, helium, krypton, ozone, methane, all these other gases. But remember, those top four are the ones you need to remember, okay? So layers of the atmosphere. So we've got, the first thing you need to know are the layers in order. Troposphere. It might be hard to see this. You can find this in chapter 18 in your book. It goes troposphere is at the bottom, then the stratosphere, and then the mesosphere, then the thermosphere. Now in between each layer, you have that transition between where one layer ends and the other one picks up. And when that's happening, right, we call that a pause. So in between the troposphere and the stratosphere, we have the tropopause. In between the stratosphere and the mesosphere, we have the stratopause, right? And in between the mesosphere and the thermosphere, we have the mesopause, okay? So what you guys are looking at here, this is temperature here in the bottom, and this is height, kilometer, right? How many kilometers away you are from the surface of the Earth. So here, 0 degrees Celsius, this goes negative, so this is getting really cold, and this is positive, and this is getting really warm, okay? So you can see as we move through the troposphere, right, we are actually, since we're leaning left, getting colder. And that makes sense, right? Because imagine yourself looking at a mountain. You know that it's typically colder at the top of the mountain, the alpine habitat, than it is at the base of the mountain. So why is that? Why do we see this decrease in temperature? That is because the Earth, right, when it accepts the solar radiation from the sun, right, it takes it in, and then it re-emits it as blank radiation. So it's, the term I'm looking for is heat radiation, which is radiant energy, right? So it re-emits that solar energy as radiant energy. And what it does is, the closer you are to the surface, the more of that radiant heat energy you're getting from the Earth. So the farther away you get, the less of that radiant energy you're getting from the surface of the Earth. Okay. Now you get to the through the troposphere and you get into the stratosphere, and it starts to warm up. What's causing that heating? To answer that, we need to know what is in the stratosphere that is beneficial to us. The answer to that is the ozone layer, right? Ozone, O3. There's a reaction between oxygen and UV light, and it forms ozone, 3 molecules of oxygen, and it absorbs all of that UV light from the sun, or a large percentage of it. And as it's doing that and absorbing that UV light, it's holding on to it, and it heats up. So you get an increase in temperature. Okay? Then you get through the stratosphere, and in the mesosphere, there is not enough ozone to really absorb any UV light, so the temperature starts to cool down again. Then you get out into the thermosphere, all right, and all of a sudden, boom, you see, again, a dramatic increase in temperature. Well, out here, there's been a breakdown of the ozone, right, and it's gone out and stretched out into the thermosphere, and what you end up happening here is you end up back to having molecules of O2, oxygen gas. And that oxygen gas that's there, even though there's a very, very little of it, it does a great job absorbing heat energy from the sun. And that's why you get that increase in temperature in the thermosphere. But here's a little side note. 99.9% of the gases in the atmosphere are from the stratosphere and below, right? So they exist in these two layers. So the gases out here are so far apart and stretched apart, right, that most of it is open space with no gas molecules. So yes, up here in the thermosphere, you can have a molecule of oxygen that is 2,500 degrees centigrade, right? You're like, man, that's really, really hot. You'd be burning up in there. But in all actuality, you yourself would not feel warm because those individual gas molecules are so far apart, you're not coming in contact with them. Does that make sense? So you yourself would feel cold in the thermosphere, even though the actual gas molecules themselves are really, really warm. Make sense? Good. So, layers of the atmosphere. Troposphere has 75% of the mass of air. It is roughly 17 kilometers thick. The stratosphere extends from 17 kilometers to 48 kilometers above the Earth's surface. The mesosphere, 50 to 90 kilometers. Thermosphere, 90 to 110 kilometers. Okay? So again, between these two, the stratosphere and the troposphere, you end up having 99% of all of the atmospheric gases held into these two layers. Okay? Another little fun fact about the troposphere: all of your weather takes place in the troposphere, and all of your plane flight takes place in your troposphere. Okay? The reason for that is flight. You need air molecules to create lift, right? Lift is a product of air passing over and under a wing at different speeds, right? Now, without any air molecules, once you get through the troposphere and the stratosphere, the atmosphere is too thin to be able to produce that effect, that lift that you need. Stratospheric ozone layer, produced by O2 interacting with UV radiation. Here's the chemical formula for it. It is our global sunscreen. It's before we had the ozone layer, right? You go back to archaebacteria 3.5 billion years ago. You have organisms that did not produce oxygen, right? So without oxygen, there could never be an ozone layer. And had it stayed like that, had life stagnated, we would never have advanced life because UV light is damaging. So what we needed first was for these bacteria to become photosynthetic and produce oxygen as a waste or byproduct. And as they continue to do this, right, and that oxygen, right, rose through the troposphere into the stratosphere, it could then react with the sunlight to produce the ozone, which then began to protect these organisms from UV light. And then life could adapt and become more complex because they didn't have to be worried about being damaged by all the UV light. So it absorbs most of the shorter wavelengths of UV light, which is damaging to living things, causing cancer, cataracts, sunburns. It allows life to live. Ozone depletion is a reduction of the ozone layer. And one thing to note, they always say that, like, when we hear about the ozone hole, there's a hole in the ozone layer, right? It's really not a hole like you would think, like a hole in your sock. It's more like a thin spot in your sock. And what I mean by that is, you got this favorite pair of socks, and you keep wearing them. And then also you look at your heel, and there's not a hole yet, but you can see, there's just a few fibers holding it together. It's real thin there. That's what the ozone holes are really like. So it should really be termed the ozone thin spots. All right? I think that's it for this section. Boom.